Hi everyone. This video is part 3 of 4 of a series of tips and tricks videos to quickly get started with Lumerical scripting and Python API. In this video, I will demonstrate how to repurpose existing Lumerical scripts into functions that can be used by the API. First, we will open the example file named Lumscript. A copy of this file is provided in the zip that accompanies this video. This script file creates an FDTD simulation parameter sweep based on the declared waveguide width ranges on lines 4 to 6. Here we will sweep for a wavelength of 1.55 microns from widths 200 up until 800 nanometers. In lines 14 to 16, we declare arrays that will be used to store the simulation data. Note that Lumerical uses MATLAB data structures. For those unfamiliar with MATLAB arrays, a key difference to know is that they are indexed starting from 1 instead of the standard 0 for most programming languages. This can often be the source of errors when trying to access the array's contents. Next, line 18 declares a for loop using the waveguide width ranges. Inside this loop, we will first call switch to layout. This is the equivalent of returning from analysis mode when using the GUI back into the layout mode. This enables editing of the geometry objects. We then update the waveguide width property on line 20, then call find modes, and write the results to a variable n. Afterwards, for each mode we are interested in, we extract the n effective value and store it, as seen on lines 22 to 25. Of particular interest here is how the n effective is accessed. You can extract the value by calling the getData function and then specifying the FDE object, the data category, and then the mode number, and finally the data you're interested in itself. Here it'll be n effective. The pathing string here uses a double colon to access each level of the hierarchy. You can see the extractable data available by selecting in the object tree on the left, FDE, then under that, data, then the mode of interest, and under the results window below, any of the results or raw data can be extracted with this method. For example, if you would like to access mode 1's group index data, the pathing would be FDE double colon, data double colon, mode 1, and then comma, NG. Back to the script. Once the simulation loop is complete, you can stage all the data for exporting by writing it to another matrix, as shown in line 29 to 31. You can also perform limited data analysis through Lumerical as it has MATLAB capabilities built in, such as line 33, which plots the waveguide width versus n effective. Next, I will demonstrate some adjustments you can make to repurpose this Lumerical script into a function that can be called by the Python API. This is especially useful for design teams that have become familiar with Lumerical's GUI and would like to move into a GUI-less scripted simulation. The functionalized script is provided in the file titled Lumscript function. The first change occurs on line 1, where we encompass the whole script file under a function declaration named calculate effective index sweep width. The parentheses that follow this declaration will determine what and how many variables need to be provided to the function when it's called. Next, we will remove our previous parameter declarations and instead insert them here in the function, allowing the variables to be provided by the Python side later. The remainder of the code remains the same until the very end. And instead of writing the arrays native to Lumerical, however, as we previously did on lines 29 to 31, we will instead add a return call at the very end of the function. Here, we specify to return the variable n effective. This will allow the contents of the n effective array to be stored in memory on the Python side. With these changes, the script has been remade into a function and can be called after this file is imported within the code on the Python side. Finally, I would like to also mention line 26, which I have left as a demonstration. Upon execution of this script from the Python side, GUI functions, such as the plot call here, will still be executed. However, it will not be particularly useful because upon completion of the script, the GUI closes. One method around this is by adding a manual pause with a user input escape. if you wish to display the plot within the GUI. You can find an example pause script from video 2 in this series. However, a better practice would be to perform the data analysis on the Python side, as it has many more libraries and features that can be accessed. The next video in this series will demonstrate the whole simulation process from within Python. This brings us to the end of this tips and tricks video. Thanks for watching.